Hi, Varun and Nagula.
Hello, yes, sir. Hi, sir.
Yeah, I'll go with Varun first of all.
Okay, sir.
Yeah, Varun, can you introduce yourself briefly?
Yeah, good evening, sir. I'm Varun Singh from Hyderabad. I completed my graduation in 2022 from St. Mary's Engineering College from ECE branch. In my college, I have done my major project on IoT-based smart parking in metropolitan cities. I have completed my training from Solid IT. This is all about my education. But coming to my experience, as of now, I don't have any professional experience, but I have very good knowledge on physical design. Based on that, I have done 2 projects, and this is about myself.
Okay. Okay.
Yes, sir.
Nagula, can you briefly introduce yourself?
Hello, sir. I am Prithviraj from Hyderabad. I recently completed my BTech in 2022 under the stream of Electronics and Communication Engineering from Karimnagar. Yeah, currently I am doing training as Physical Design Engineer from Sumedha IT Hyderabad since April 2022. Energy notes and hands-on experience on DC Shell, Prime Time, and ICC Studio.
Okay. Okay. Varun Singh, make sure that you don't have any background noise. Okay.
Yes, sir.
Okay.
Yeah, sure.
Yeah. Varun, can you give some brief differences
Yes, sir.
between latch and flip-flop?
Latch and flip-flop means actually latch does not require any clock signal. Flip-flop will be have clock signal, and latch will be it is an synchronized device. It is a level triggering. Um, Actually, it works on based on enable pin and it requires powerless. It requires power required less.
Yeah, may I know the
And
reason, Varun? Why the power requirement is less for a latch?
actually, when coming to flip flop, it requires more power to change the this
Yeah, that's what. Why?
digits.
Why latch requires less power? Flip-flop requires more power.
Means,
Okay. Nagula? Yeah, Varun, it's okay. Nagula?
yeah.
Nagula,
Sir,
yeah. Hope you know, in our
Okay.
design, we don't use unintentional latches.
Yes, sir.
What is the reason?
Because we need to control the device under by using flip flops, because we can control the design because flip flops are edge level triggered, edge triggered. We have more control over our design.
So you mean using latch you cannot control. Is it right?
Yeah, more than not more than these flip flops. Yes, sir.
But in clock gating, ICG cell, we have a latch, right?
I see.
Do you know
Yes,
clock
sir.
gating cell?
Yes, sir.
Then? Okay, Varun, can you give a
Yes, sir.
definition for synthesis?
Uh, Mm, Actually, synthesis is nothing but we take um, mm, actually synthesis is nothing but we take an RTL program that in terms of logic gates that would translate into this high level language.
Language. So is synthesis output
Mm,
a language? Okay, Nagula, can you define synthesis?
Synthesis is a process of converting RTL code to gate level netlist, which is technology dependent, which consists of sequential circuits, combinational circuits, and their connectivity.
And their
Basically, yes, sir. Basically, textual representation of RTL code is converted into technology dependent gate level
Okay.
netlist.
Okay. So you are converting from RTL code to gate level netlist, right? Do you have
Yes,
any
sir.
goals in that? Means while converting, do you have any goals? I mean, I want to know what are the goals of synthesis.
To check this RTL code
goals?
and the
Yeah, continue, Nagal, continue.
yeah, okay. To check whether this RTL code and our gate level netlist is perfectly matched with this design performance. To check whether the textual representation matching with the gate level netlist after the synthesis.
How are you saying performance? In what parameters?
Sorry, performance like design. With what we have implemented in RTL code is same as gate level netlist by the gates with the combination of all gates.
Actually, for your kind information, synthesis contains 3 stages: syn generic, syn mapping, syn optimization, right?
Yes, sir. Yes, sir. Translation, mapping, and optimization.
So in
Optimization and mapping.
that optimization,
Okay.
what are you going to optimize?
Optimization.
Logic optimization.
Okay. Varun?
Logic optimization will be done, sir, in optimization.
Varun, do you know about sanity checks?
Yeah, sir. Yeah, I know 76.
Yeah. Can you describe briefly?
Actually, before placement, we check library, check time, check design, and check netlist, sir.
No, Varun, we are at synthesis one. So don't go for PNR.
Okay.
Yeah. Take synthesis.
Yeah. So in synthesis, we will. I mean. We will also check clock latency and uncertainty, transition time, input delay and output delay, and false path and multi-sector path, and we also check area also. Yeah, that's it, sir.
Nagula?
Sir, basically for
No,
synthesis,
just a second.
we
Just a
uh,
second. Just a second. I want to know that the difference between sanity checks in synthesis, sanity checks in PNR. Do you know the difference?
basically sanity checks. Yes, sir. Sanity checks are generally for a full plan. We check design, check place, check timing. Like that, we are checking whether the design is matching or not. After in placement, check tab cells, check well tab cells, end cap cells, like that.
Report queue or report.
Okay, in Nagula, can you briefly explain what are the contents present in .sdc file?
We are create clock, create generate clock, set clock latency, uncertainty, driving cell load. Uh, that's it, sir. Input clock latency is input latency out. That's it, sir. Generally, we are constraining the clock, giving constraints.
You said generated clock and clock, right?
Yes, sir.
Do you know the difference between propagated clock and generated clock?
Generated clock is taken from the original clock with the factor by multiple by divided by, like that, sir.
Propagated clock?
Propagated clock means source clock.
Is it source clock?
I now got that propagated clock means whether you are asking about source clock.
No. I want to know the difference, right?
Difference between generated clock and virtual clock.
Okay.
I know.
Okay, Nagula,
Yes, sir.
you are aware of synthesis environment, right? Synopsis environment, right?
Yes,
Means
sir.
you worked on synopsis environment.
Yes, sir.
Like in your synthesis, did you get any word? Did you come across the word called linking?
Yes, sir.
Yeah. What is meant by linking?
By library cell, sir. Set link library. By using that set link library, we are mapping the all library files that are called by the RTL.
Are they library files or even RTL files as well?
Sorry, sir. No, sir. Library files.
Only library files, right?
Yes, sir.
Like, do you know, like the word is exactly similar to linking in Cadence environment?
No idea about Cadence.
Varun?
Yes, sir.
In which environment you work? Is it Cadence or Synopsis?
No, sir. Synopsis.
Okay, you both from Sumedha IT, right?
Synopsis. Sir.
Okay. Understood.
Yes, sir.
Okay. One straight question to you, Varun.
Okay.
Hope you know about DRVs,
Yes, sir.
right? In which file
Yes,
it is present? The DRVs.
Actually, PRV is nothing but design rule violations. Actually, it will present in a like transition time and set like that, sir.
No. I'm asking you in which file that information is present. I'm asking.
Actually, I have seen in PNR, sir, in PD.
So no
the
DRV,
placement stage I
no
have been.
DRV, no DRV information synthesis.
Um, no, sir. Actually, I got a setup and whole violations. That's it in synthesis.
Okay, tell me what are DRVs, Varun?
Um, DRV is um, report QR, report sending.
Nagula, can you tell what are DRVs?
Max tran, max cap, max fan out, sir.
Max cap.
Yeah, correct, Nagula. Okay, Nagula, straight away to you.
Okay, sir.
Coming to placement and route, I mean PNR.
Okay.
Hope you know the macros occupies too many layers, right?
Okay.
And yes, macros has pins till layer 3, 4, 5 like that. What is the reason?
No idea, sir.
No. Okay. Varun,
Yes, sir.
can you give some macro placement recommendations?
There are a few guidelines to place a macro, sir. Actually, you are saying about guidelines, right? Yeah, yes, sorry. We have to place macros around the core region. We have to give sufficient macro, space between macros we have to give, and then we should apply the keyboard margin. Do not place a macros in between the core region. It may create congestion in further steps. And we have to place the macros based on the hierarchy, and we have to place it all close together. And there is a point. Yes, sir.
Varun, do you know the difference between
Yes,
a
sir.
standard cell and a macro?
Yes, sir. Actually, macro means we can't able to see the inside functionality. In standard cell, we can able to see functionality.
Okay. Have you seen a standard cell functionality in your project? Whatever you have done, I think you said 2 projects you have done.
No,
Have
sir.
you seen the functionality?
Yeah, but no, sir. Actually, I didn't see a functionality of standard cell.
Okay. Nagula,
Sir.
suppose, like, hope you know, we place the standard cell through GUI, right?
Yes, sir.
ICC to
Yes, sir.
GUI.
Yes, sir.
If I give you like from terminal, you want to place the standard cells. Do you know the command? What is the command we use to place the standard cells?
In floor plan stage or placement stage, sir?
Anywhere. I want to place the standard cells. What is the command we use?
No, sir. No, sir.
Okay. Okay. It's okay. Yeah, Nagula, to you.
Okay.
we have various physical cells, right?
Yes, sir.
In which stage we use, we insert antenna cells, antenna
Antenna.
diode cells. Yeah.
Antenna diode cells.
Okay, or at least Nagula, tell me, like,
Yes, sir.
why do we use antenna diodes? Do you know any process antenna effect?
Yes, sir. And to reduce the antenna effect, because during metallization, uh, so many what I mean to say is during metallization the die may undergo several process. Some ions get placed over the metal which act as antenna. Due to that, some voltage drop will occur. To reduce that voltage drop, we are placing a Xeno diode as an antenna diode to nullify this voltage drop.
Is it a drop or is it a voltage drop?
Through that antenna, voltage drop will occur, sir.
Which antenna?
Not antenna. Some of the during metallization, some of the particles get over this gate terminal, which act as antenna, which drops our
That's
preferred
what Nagula. Which one is acting like an antenna? I'm asking you.
gate terminal, sir.
Suppose we have not used antenna cells. What's going to happen?
Voltage drop will occur, sir.
So that
what we are targeting voltage is not getting to the cell, and delay will increase.
delay will increase. Okay. Other than Xena diode, do you know any other techniques to
Sorry,
avoid
sir?
process antenna effect? No. Other than Xena diode, do you know any other methods?
To reduce antenna effect. By metal shielding, sir.
Metal shielding.
Means allow or spacing by increasing the spacing.
Any other?
Layer hopping?
Metal hopping, sir.
Layer hopping is a better option to us always.
Yes, sir. Yes, sir.
Yeah, Varun, what is layer hopping?
Layer hopping is nothing but it cuts the metal wherever we required, and it jumps the higher metal layers.
Okay. If you go to higher metal layer, what is going to happen?
Actually, it provides a less resistant path.
Okay. In your project, have you done metal like layer hopping?
Yes, sir. Yeah, actually, we got at metal 5. So metal 5 to metal 3.
Then metal 5 to metal 3, it is coming down now. You are saying metal layer means next higher layer, right?
Next higher layer.
Then how come it is metal 5 to 3?
Sorry, from metal 3 to metal 5.
Okay. Why not metal 4, Varun? Because even metal layer 4 also higher layer only, no?
Actually, as we see, from odd numbers will be in a horizontal, the even numbers all in a vertical, like that. So it jumps from metal 5, metal 3 to metal 5, because both are in a horizontal lines. horizontal computer.
Okay, why the layers? I mean, they formed in a horizontal, vertical way. Any standard reason for that?
As I think both and horizontal and vertical layers uh, will be easy to routing the standard cells or like that, sir.
It is only for making easy routing? They consider
And
horizontal,
to
vertical.
avoid the shots.
Mm-hmm.
According to me, to avoid this capacitance effect, sir.
Right. To reduce the coupling capacitance.
Capacitance, yes, sir.
Yeah, to reduce the coupling. Yes.
Okay, Varun, do you know the purpose
Yes,
of spare cells?
Yes, sir. Yes. Actually, space cell is nothing but those are extra standards that are added in the code region, which can be used in further engineering change order. They can be added at any stage, but we prefer to add in a placement. Say that they don't have any logical connections.
You said standard cells are adding, that means you are considering spare cell as a standard cell only, right? And now you are saying no functionality.
They are extra standard cells, sir.
Yeah, if it is extra standard cell, how can you say no functionality?
No functionality means they don't have any logical connections, sir. By default, all input pins of spare cells are connected to ground.
Okay, can I think spare cell is a standard cell? Can I assume like that?
Yeah.
If it is a standard cell, it might have some function, right?
Yes. But
Okay, Nagul.
Sir, spare cells are not the standard cell, but it is a physical only cell which do not have any logical based connectivity. Basically, they are used to, which is this is a technique to increase the yield, chip yield, to increase the chip yield, and this can be used further during in future if we want to add some more cells in our design. We can use these spare cells. Before that, spare cell is connected to VDD and VSS. If we, is there any chance in our design to use this spare cell, we can detach them with the VDD and VSS, and we can directly use in our design.
Now, why do we want to use them? Because it doesn't have any functionality, right?
Yes, sir.
Then why do you want to use it?
Actually, with the spare cell, we can use for hold violation to reduce the hold violation, sir. Actually, it acts as a buffer.
Okay.
Yeah.
Varun, please just briefly explain CTS. Someone is moving papers, I guess. I can see the tearing sound.
Actually, right now I'm in gym, sir.
Gym?
Okay. Yes, sir, gym.
Yeah, Nagula.
Yes, sir. Yes, sir.
in clock tree synthesis, the tree is different types like a H tree or
H
inverted
tree.
tree like that.
Yes, sir.
In your project, what kind of tree it was? Like you have
Conventional
done
trees.
projects,
Conventional trees.
conventional tree. Okay.
Yes, sir.
In that,
Uh,
you might identified some clock buffers and clock inverters, right?
Yes, sir.
So no more buffers or inverters, only clock inverters, clock buffers, right?
Okay.
Do you know the basic difference between clock buffer, normal buffer?
Clock buffer, normal buffer. I know, sir, but I forgot.
Okay, no problem. Varun, do
Sir,
you know about temperature inversion?
yeah, sir. Yeah, I know
Yeah.
temperature inversion. Hmm. Actually, temperature inversion is nothing but when higher nodes like greater than 67, I mean 65 nanometers cells. In that sense, we can have like
So you mean temperature inversion happens above 65 nanometer?
actually actually in lower actually in lower nodes the delay will of the cell will decrease due to
No, no, no.
increase in
No,
temperature. So,
no, please give me clarification. Temperature inversion happens
okay.
above 65 nanometer or below 65 nanometer?
Actually, below 65 nanometer, it will happen, sir.
Hmm.
Actually, lowers so the delay of the cell decreases, so
Okay.
it increases in temperature.
Nagula,
Yes, sir.
uh, actually, above 65 nanometer, we have three corners, right?
3.
Corners.
Yes, sir.
If it is below 65 nanometer, may I know the
Okay.
corners? How many corners and what are those corners? RC corners.
RC corners. C best, C worst, RC best, RC worst.
Four.
4, sir. And PVT corners also, sir.
Typical and
That are PVT corners.
Okay. Varun, can you describe about VT
yes, sir.
swapping?
Um, VT swapping means changing the drive stance, higher drive strength to lower drive strength.
No, it is not drive strength. VT. What is VT? Threshold voltage.
Threshold voltage.
Nagula, do you know about
Basically,
sign up?
there are 3 types of cells: LVT cells, HVT cells, and LVT, HVT, LVT, SVT. Cell swapping,
Yes, okay.
VT swapping means changing of cells between HV to LVT, LVT to HVT to increase the drive strength, to delay. What are the goals? If we have the goal to decrease the delay, we go for HV to LVT. For that reason,
Correct.
we are changing those cells. That is VT
If you
swapping.
change from HVT to LVT, Yes,
Okay.
according to you, yes, that is correct only. The delay reduces.
Okay.
Did you get any side effect for that?
More power dissipation, sir.
Higher
By
efficiency.
using
Yeah, exactly. Exactly. Nagula, do you know about logical restructuring?
logical structure. No idea, sir.
Okay. Varun,
Yes, sir.
what is meant by clock jitter?
Actually, clock jitter is nothing but um, it is an deviation of clock edge from its ideal location.
Okay.
Yes.
What is what is the side effect for that? Because of that clock jitter, did you get any?
Mm, due to that, it get a timing violation, sir.
Okay.
Mm,
Nagula,
Yes, sir.
coming to the clock skew,
Skew. Okay.
yeah, there is a positive skew and negative skew, right?
Yes, sir.
Do you know about useful skew?
Useful skew is nothing but we are intentionally adding the delay to
Okay.
meet our timing requirements.
Mm-hmm. Okay. What are the STA inputs, Nagula? Are you comfortable with STA?
Yeah, yes, sir. STA,
Okay.
netlist, SDC file, SDC, and spec file library files, sir.
Yeah. Uh, uh, yeah, Varun,
yes, sir.
uh, do you know about spec file?
Mm,
What it contains? Spec
yes,
file.
sir. Yeah, yeah. No. Um, uh, so, um, actually, it consists RNC values of all the nets and standards of value and parasitic extraction format. Yeah, it contains resistance and capacitance values of all nets. Sir.
Nagula,
Yes, sir.
so hope you know zero wire load model analysis, auto wire load model analysis like that, right?
Okay.
The tool by default it selects zero wire load model if you don't give any command.
Yes.
I want to know in which file the zero if you want to give as a custom wire load model or auto wire load model, in which file it is present.
I think TLU plus file, sir.
TLU plus file. Okay. Do you know the full form of TLU?
Table lookup, RC coefficient.
No.
No, sir.
Look up to.
Yeah. No. Okay, Varun.
Yes, sir.
See now the last question to you.
Okay.
You know the difference between cost group, path group.
Sorry?
Path group and caste group. What are the differences?
Mm, mm, no, sorry, sir. I don't have. Actually, I didn't remember him.
Okay, no problem, Varun. Yeah, Nagula,
Yes, sir.
the last question to you.
Okay.
You tell something. What do you know about scan chain reordering?
Scan change reordering.
Yeah.
Scan change reordering means properly arranging the nets between the each and every flip flop to reduce the net delay, overall delay, sir. If there are number of flip flops, if any in our design, if any number of flip flops having connectivity between each and every flip flop, we are ordering them in a sequential manner to decrease the overall delay by connecting them sequentially.
Okay, then why do you use this scan chains? It's better to you can skip now. Why again reordering? I'll agree. Whatever you said, 100% is correct.
Okay.
We do reordering to reduce the delay. Agreed.
Yes, sir.
But why do you require scan chains?
It optimizes the price. It optimizes.
Is it optimizes? If it optimizes, like if it optimizes, then what is the reason? Like why we need to reorder again?
Actually, it optimizes the place of stitching flip flop registers, now, sir.
No.
Sir?
So hope you know scan chains is it for DFT, design for
Yes, sir.
testing.
Okay. Design
We
for
take
testing.
scan chains for DFT.
Okay. To test the design at any stage, we are inserting this some of the modules. I think so. Modules into our design to test the design, to test our module. I think so.
How you test Nagulu?
I don't know, sir, but I read once. That
Mm-hmm. Yeah, that's it. Varun and Nagula. Rajat.
Okay.
Yeah, Rajat, over to you.
Yeah, tell me.
Yeah, over. It's over to you.
Okay.
Like, my part
So
is
you want
done.
to give the like feedback to the feedback, any improvement or something?
Now itself.
Yeah, you can give
sir,
now.
this okay.
Rajat, you mean now can I give?
Yeah, you can give now itself. Now itself is fine.
Okay. Varun, you need to improve a
Yes,
lot.
sir.
Like
Yes,
I
sir.
tested you in
Actually,
basics, in synthesis, and in PNR, in STA. Whatever the questions I have asked you,
yes, sir.
around 10% the correct answers. What I observed
Yes,
is you
sir.
are getting confused. You're in a confusion stage. I don't know, like whether it is the right time or not to give the interview, but you totally confused and you are taking more time to give the answers. That's what I found.
Yes, sir.
You need to, yeah,
Right now I'm at gym, so I got confused for few questions.
okay, yeah. Is it your first mock
Sorry.
interview?
Yeah, actually I have gave for few companies, and I have got two offer letters, but their package is very less, so I have rejected that. So I'm looking for a better package. So this is my first mock interview, sir.
Okay, but try to see that because Varun, I can say you may have offer, but when you get to enter into live projects, you may feel some insecurity or you may feel some like lagging in the concepts and the projects. So please,
Yeah, actually,
please take it as a just a feedback like that, as a
Yeah,
from our side, and you work on it.
yeah,
Okay.
yeah, sure.
Yeah. Yeah. Coming to Nagula,
Yes, sir.
yes. Whatever you like, the way of giving the answering is good. If you know the
Thank you,
content,
sir.
you are expressing clearly. But still, in PNR part, like I felt a little lag.
Okay, okay, sir. This is the first second mock
Oh,
interview, sir. Second mock
then
interview.
then it's okay, because after giving some 3 to 4 mock interviews, you'll
Mm.
understand the flow. You can convince the interviewer with your answers clearly.
Okay,
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 good
sir.
good Nagula, and if you ask me the rating, I can give you uh, 5 out of 10.
Okay, sir. Thank you.
Still
No problem.
still there is a improvement. I agree, because of this second interview you may be, but try to improve that. You work on it, Nagula.
Okay, okay, sir. Sure.
Yeah, it was nice talking to you, Varun and Nagula, and I wish you all
Yeah.
the best.
Sir, one thing.
Yeah, right.
This once you asked about TLU press file, that answer I told. What is the question I forgot?
See, you said TLU plus file, and
That's the answer. I don't know
you
the question.
see, without question you have given the answer.
No, no, sir. I remembered, but I forgot.
Mhm.
Varun,
You asked
you
Sir,
have
me.
any idea? Okay, sir. No issues. Okay.
Okay.
sir,
Okay,
Thank
Rajat.
you.
Yeah, Rajat, over to you.
Yeah,
sir,
sure.
Varun, do you have something to say?
yeah, sir. Actually, I have a question.
Yeah, yeah,
One of an interviewer asked me this question. Can you please give a clarify to me, sir?
yeah. I'll try. Yeah, you can
Yeah,
ask me.
actually, um, actually, for 28 nanometer, for example, they have 9 metal layers. Okay,
Okay.
so we have routed only 6 metal layers.
Mm-hmm.
So what happened to if we have only routed only 6 metal layers? What will happen, sir?
No, actually, let us assume 8 metal layers or 9 metal layers. We do
Okay.
routing between second to 6 mostly, because
Yeah.
the top 2 metal layers for power routing,
Power one.
means for power
Yeah.
connections.
Yes, sir.
If it is 9, let us assume 9 and 8 are for power routing,
Power.
and
Yes.
the next tool for CTS, means clock. Hope you know the
Okay.
clocks is the major contribution in the power. And
Yes, sir.
afterwards, the remaining layers except M1 layer, because M1 layer has pins.
Standard, sir. Yes.
Yeah, standard cells are present in the base layer, and their pins present in the M1 layer.
Yes, sir.
That is the reason. Like if there are 9 metal layers, we don't use 9 metal layers for routing. The top 2 layers
Uh,
for power routing, and then CTS,
yes, sir.
and then
Yeah, this is what I have said to him, sir. But he said that is wrong. There will be another answer. Please Google it. He said, sir. I have asked so many faculties about this question,
maybe
but
we don't know what is his intention, what is in his mind. But
okay.
as of my best knowledge, that's whatever I said, and what you understood. It's mostly correct.
Okay, actually, he said there is another answer. So,
Mhm.
Sir, when you asked that macro pins are placed at different layers, why?
Hmm.
M1, M2.
See,
Sir, M1,
macro is a bigger standard set.
yes, sir.
So if it
To
is
decrease this,
it is
okay.
yeah, it is just like it's a big apartment. In and around there are small houses.
Okay.
So coming to suppose if macro pins are not present in multiple layers, standard cells, whatever the routing connections, or else the connection should come down to M1 layer. So
Yes.
there might be congestion.
Okay, we may get routing issues and pin density issues.
That's it. That's it.
Okay, okay. Okay, sir.
Okay, Rajat, over to you. Rajat? Rajat?
Sir,
Rajat?
Sir, Abhiram, sir.
Yeah.
When will be the situation will be?
No, we can't say, Varun. People are saying 2 months, but my friends are working in AMD and other product-based companies, and they said by this month the net list may come. If the net list comes, we may have the jobs. Otherwise, we need to wait for 2 to 3 months. So according to them, that was the that is the present scenario. Yeah. But
Actually,
believe,
now it is. Yes, sir.
Till then, believe in yourself, and you need to prepare well, and you need to get the expertise in tool. That only makes sense. If you are weak in concepts, also they don't care. How far you use the tool is
Yes,
most important to them.